today was to just look at some polar, okay, and then I can answer some questions. All right, and I believe these were actually on one of the homework assignments. I stole some from the homework assignments. I stole 2 different problems from homework assignments. I'm not going to do the whole problem. I was just going to do the setup on the problems, okay? So, because I know that's this is probably out of this section, out of this unit, this is probably, I'm guessing, kind of where we're struggling the most, okay? So I'd like you to struggle a little less on it. So again, I'm not going to actually do the integration. Likely on the test, I'm going to probably say set up but do not integrate, okay? These are 2 that are not on the review, but I'm going to say are fair game for the test, okay? So whatever I do in class, remember that's a good emphasis, means I'm going to be looking at it on the test. The test is probably going to be 10 questions long-ish in that area, okay? Because that's doable in a class period right now. And we'll of course apply the AP curve to it. So just as always, you have to get about 5-ish right to pass, okay? Probably about 7 to get an A, all right? I gave you whatever the bank is of question. I think there's like 15 or 16, I think. I don't know, I might be mixing it up with AB on the review. So I'm going to kind of stick to there and whatever I do in class. Okay, I did not get one of these on because it was too much for me at the moment when I was trying to write the review. All right, we ready? So we've got to find the area, right? The good news is that polar, we don't do volume. We only do area. Okay, so if you actually get a polar question, you only have to deal with area. You don't have to deal with volume. So we are, when I do the area of a polar, okay, what does the formula start with? You tell me that in the chat. What does the formula start with? I want to hear from everybody, so I know you're all here paying attention. And everybody needs to help me. Hello, David. So far, I see 5 people helping me. I need more. All right. Okay, so we're going to start with 1/2. Get that written on the paper. So the other day, I was watching Mark and Verge the other day because the AP review thing started, right? I think you guys know who Mark and Verge are from last year. So I watched the AB one live. I was able to do that the other day. Well, I didn't even mention them because I know we were busy trying to get ready for this test this week. We'll watch live next week. Or actually, we'll have to watch them recorded because BC's at 2 o'clock. And she suggested take a piece of paper as you were going through the reviews and start writing down the important stuff. So this is one of those things where for tomorrow's or Friday's test, I would write this down, right? The formula for the area of a polar, right? Which is 1/2 the integral of the function squared d theta, right? And whatever it is, a to b, alpha to beta, whatever you want to call it. Okay, so I would have that. You could grab that piece of paper right now, write that down. Then you're not flipping through your notes during the test. You got it right there in front of you. Okay, take advantage of this probably being the last major test that goes in your grade and the fact that it's open notes versus the AP test, which is not going to be open note because you're going to be taking it in person. Okay. All right, so let's talk about, I know, so Gabby and I have talked a lot about these, so I want to make sure everybody else is kind of in that same page, okay? So I'm going to ask Gabby to kind of be quiet for a little bit. You can add on once everybody else is in the chat, okay? And I still want to make sure you know it, Gabby, but I know that we've talked about it, all right? And I want to make sure everybody else is here and dealing and getting this. All right, so I know I'm going to start this with 1/2, okay? And really, I know that inside here is going to be this function, right? And I can either write this, and this is supposed to be a theta. It just didn't, the place I stole this from, it didn't, whatchamacallit, it didn't print well. So I could either write the 2 cosine 2 theta, or I could just write r, couldn't I? I'm going to write r of theta, d theta. Super easy to get that part done, right? The hard part is what are the bounds, okay? So when we do polar, we always start at the pole, okay? So I'm going to start here. What's the value of the angle at the pole? Can everybody put that in the chat for me? The value of the angle in the pole. Everybody help me out. This is not a hard question. Where do we always tend to start when we integrate? Think about that. I had 3 people. I should have more. Okay. Got a few more. We're going to start at 0, right? That's the poll is. We're start at 0. Yes, don't overthink it, right? This is not hard. 0. Okay, so I'm starting at 0. Now I got to figure out where I'm going to, okay? When we're doing polar, take advantage of symmetry, okay? Because if I start at the pole, when I come out from the pole, I would hit, my spray paint would hit right there, right? And then I'm going to keep going this way. Okay, so if I find that top half, I'm noticing it's symmetric to the bottom half. Okay. All right. So it's symmetric to the bottom half. So if I can get the top half, what would I have to do to get the bottom half? What could I do to the whole thing to get the bottom half? What do you guys think? Lorenzo put an idea. Do we agree with that idea? So if whatever my area is, purple area on the top, what would I have to do to that area to also get the bottom? Everybody read what's in the chat. See if you agree with it. All right, good. All right, so I'm seeing a lot of doubling. Okay, so I'm going to go with that. So that's this, and again, this is one way to do it. Okay, so I'm going to double whatever I get. I still haven't figured out that bound. All right, the one and only thing I know is that I know that my function is equal to whatever it is at the pole, right? So couldn't I set this equal to the pole? And again, think about it. As all else fails, don't we set stuff equal to 0? It's a good place to start. So we're to get our bound, we're gonna take this and take our R. And oh, that was terrible. And now it's not erasing. Oh my goodness. I erased I had the answer all covered up. I forgot that it was there. Okay. We're going to set it equal to the pole. So R equals 2 cosine 2 theta equal to 0. All right, I'm going to solve that just like we would have solved it last year and the year before in trig. Okay, 0 is the pole every single time. Okay, it's like the origin. So it's the origin of polar is the pole. Okay, so I'm going to divide by 2. I get 0. So let's see, I'm looking at my unit circle. So help me on the chat. I need to reverse cosine, which is kind of like doing an arc cosine. I was actually teaching this lesson to trig today. What radian measures, okay, is cosine equal to 0? So what are the two? There should be 2 of them. What are the 2 radian measures? Tell me in the chat. Want to make sure everybody's confirming this for me. We know what's going on. Okay, so I know that I've got pi over 2 and 3 pi over 2 are the 2 places where my x value is equal to 0 on the unit circle. Remember, I take whatever's on the inside in here and set it equal to that. So 2 theta and 2 theta. I'm going to solve for theta. So I would have to multiply by 1/2 or divide by 2. So I get theta equals pi over 4 and 3 pi over 4. Now, 3 pi over 4 is over here, isn't it? Let me use something else. 3 pi over 4 is over there. That's not helping me out right now, right? So you have to kind of use a little common sense and logic and know the picture a little bit, know kind of where things are on roughly on the unit circle. And I will give you the picture on the test. I don't want you spending time putting it in the calculator. Most likely College Board will probably give you the picture too. So I'm kind of thinking we're probably not using this one, right? We're going to focus in on this one. And this, to me, logically, looks pretty much like pi over 4, right? So I could integrate from 0 to pi over 4. That would be all you'd have to write, right? If we're going to set it up. Could you put it in your calculator? Absolutely, right? You could put that in. I'm not going to mess with putting it in the calculator part. The bounds are sufficient to get you 1 petal. That will get you 1 petal, okay? I'm going to talk about it in another slightly different way here in just a second. Can everybody give me a smiley face rating as to how we're doing? Is it a smiley face means I'm doing okay, I get it, and a sad face means I have no clue what's going on? But I want to hear from everybody. Where are we at? And please be honest, okay? Because if I need to go back to something, you've got to know this before, because we want to make sure we do good on this test. All right, 6 of us are saying smiley faces. I'm assuming the others aren't paying attention. Okay, so let's talk about another way you could do this. Same thing, okay? So we could have that way, or what if we tried to find the area of the whole thing without doubling it? Okay, so that's the next concept we're going to look at here. So let's say I've got this. That's the same, doesn't change, okay? So let's take my can of spray paint. Let's see, I'm going to make it sparkly this time, okay? And if instead of starting at the pole, I'm going to start here and take that can of spray paint and go all the way to the pole. So I know I'm going to end at the pole, end at pi over 4, not the pole. But the question is, where did I start? Could I use symmetry to help me out? Where am I starting? Put a guess as to what you think the radian measure is where we started right here. So what do you think that radian measure is right there? What does everybody else think? What's that radian measure? Even if you're wrong. I want to hear from everybody. What are we thinking? Okay, we've got some interesting ideas. Okay, so if we're going to be symmetric, right? So it definitely, there's symmetry playing there, right? This here, if this is up pi over 4, if I went backwards, wouldn't I be negative pi over 4? Okay, that's another way to count it. Lorenzo was right. 7 pi over 4 would be it is what that location is. But when we integrate, can we go from 7 pi over 4 to pi over 4? Do I have a continuous function there? Does that make sense? I can't count from 7 pi over 4 and get to pi over 4. I'd have to do the flipping thing. Yes, so it'd be, so Gabby, you're right. It would be 7 pi over 4 minus 2 pi if you're going to do it that way. Okay, or you count back 1 wedge. All right, so I could integrate it from negative pi over 4 to pi over 4. Hi, I need a smiley face rating in the chat for those of us that are paying attention. How are we doing now? Is that making sense? You can't do 7 pi over 4, Gabby. It has to be the negative one, okay? David doesn't have a smile, he just has eyes. David, can you give me Gabby's light? Okay, so Gabby, what's wrong? And David, I need you to kind of know where I've lost you. Okay, so we can't flip the integral because the integral flip is going to put us over here. Okay, it would make us go the wrong way around the circle. Okay. You're okay, Gabby? Okay. All right, so I have one more question on this one for you guys. What if I asked for all the petals? How would that change my setup here? If I asked for all the petals for the area of all of them, how would that change my setup? What would I have to do? Put it in the chat. Tell me what you think. Nobody knows what would change? How many petals are there? Can everybody tell me how many petals there are? Okay, I have 4 petals. Okay, so this is like if I find the area of one thing, right? What would I do to get the area of all 4 things? So kind of back to our like elementary, middle, it's too easy, right? Elementary, middle school days. All right. It would, so Gabby, yes, in theory, it would make it a 2 outside. You're right. Okay. I was trying to get to the concept of they multiply by 4. So if I wanted to go to if I wanted to find all 4, I would put a 2 on the I would put a 4 on the outside of these guys, which when we simplify it would be a 2. Okay. So Gabby's right about that. Okay. All right. I got one more to talk about. All right. So that's the other one. I think it was on the homework where you had to find the area between the two. And Gabby might have to help me a little bit because I'm not sure I don't think I started doing it right during second period. I didn't get through all of it though because we had less time in that class. 12. Okay. All right. I'm going to give you a minute to write whatever it is you want to write. All right. I am going to give you one where you're going to have to find the area. They're going to be overlapping somehow. Okay. So I want to make sure we understand that concept of overlapping. All right. And that is not in the Otis review. All right. So that's why I'm bringing it up here. Okay. So we are doing something that's going to prepare us for this test. All right. But I wanted to start on the other one to make sure we got that concept first, that we understood the symmetry and stuff first. So you have to be kind of careful on this one. It looks like it has both horizontal and vertical symmetry. And it probably does, okay? But it might not on the test, all right? So you got to be a little bit careful. We know that if we started here, I'm going to zoom. Okay, if I started with my spray paint, okay, at the pole, I'm going to go this way on that bottom function, okay? And then it's going to come over here. So do you see how there's definitely some vertical symmetry going on? Okay. If I started at the pole on this one, the one that's upside down, it'd be going this way. Actually, no, it wouldn't. It would go the other direction. It would go like this. It would probably go out to here and come this way to hit the walls. Okay. So what we need to do is we need to find, I can kind of do the doubling thing. I don't need that part, right? As long as I found the purple and I found the red that was on the positive half, we would have this, okay? What we need to decide though is which function is which. For that, I'd probably have to at least graph one of them. You could test a point, that would work too, okay? I'm gonna, for the ease of time, like I said, I'm not going to make you do the graphs, and it might be obvious, right? I picked one that was done already for me, but I might do like a cardioid in a circle. Okay, so it's much more obvious from the equation instead of 2 of the same thing. So let's go to Desmos super fast and just graph one of them. Uh-oh, what happened? That's not what I wanted to do. Desmos. Okay. You guys totally lost me, didn't we? Hang on. I think I accidentally closed it on that computer. I accidentally hit close. All right. All right, so it was R equals 4 times 1 plus sine theta. Okay, so I know the one with the plus is the one that's upside down. I don't need to worry about the other one, right? Because I know the one with the plus is upside down. I'm going to label mine a little bit better than that. So I know the plus sign is, I'm going to call that one R sub 1. I'm going to call the other one R sub 2. And I'm going to do that labeling on my graph as well. So R sub 1 and R sub 2. So that way I kind of know which is which. In fact, we could color code it, right? My R sub 1 was the red one. And my R sub 2 is the purple one. Okay. All right. I wrote 1 times instead of 4 times. What was that? Oh, in my Desmos? I don't think it's going to matter. It's still going to get us the, there we go. We're still upside down, right? We're still good. We got the idea, right? It's just a scaling thing. Okay. So I know what you guys tell me, what goes out in the front of every integration when we're doing area of a polar? So everybody should be able to tell me that, because it's the second time I've asked that question. What's going to go in front? Okay, so definitely 1/2. So we're going to have 2 separate equations this time, though, right? So I'm going to say 1/2 the integral of something squared d theta minus the integral 1/2. That looks terrible. That's not what I wanted to do. We're just going to write it a little bit differently. Let me just make this a different color. All right, minus 1/2. You can see my secrets. All right, something squared d theta. Because we labeled these R1 and R2, I'm going to use that to my advantage. Okay. So, actually, I'm not subtracting. What should I be doing in between the two? Should I be subtracting? What should I be doing? Yeah, we should be adding this, shouldn't we? It's definitely a plus sign in between the two. All right. So it really doesn't matter which one we start with. We could really pick whichever one we wanted to start with. I'm going to say let's start with the purple one. So that's the, let me think about that. I'm actually going to start with the red one. Okay. So my red one, I'm coming down from the pole. What's the value at the pole? So what's my bound value at the pole? Everybody tell me that in the chat. What's the bound value at the pole? All right, it's 0. Good. And then we're going to go all the way until, I don't know what this is, do we? We need to do a little bit more research here, don't we, before I actually try to figure out my bounds, huh? So what am I going to do to figure out the bounds? What does everybody think I should do? I've got some equations. There's something I can do with those? I suppose I could set to 0, but I have 2 equations that are equal to each other. Or sorry, 2 equations that I have that cross, that intersect. So what should I do with the 2 equations? I've got a couple people telling me. Good job, I messed up the question. It happens. All right. I'm going to just go ahead and set those equations equal to each other, because likely the pole value will probably fall out of that whole thing. All right, so we've got 4 times 1 plus sine theta equals 4 times 1 minus sine theta, which the 4s are going to go away, aren't they? So 1 plus sine theta equals 1 minus sine theta. Let's see. I'm going to subtract the 1 that way. It's going to be 0. I'm going to add the sign, so it's going to give me 2 sine theta. So it says sine theta equals 0. We'll let you catch up. Okay, so we're back to our good old unit circle. Where does sine of theta equal 0? What does everybody think? All right, I'm seeing a lot of zeros and pies. Is there one more place? Is there one more place? Hey, Samuel. I didn't notice you pop in. Sorry. Oh, it's also the coterminal to 2 pi. Nice. Okay, so that's probably going to give us some bounds to work with. Okay. Even though this doesn't seem like it's going to pi, look at it's kind of on that horizontal, right? Let me make sure here. Yeah. So if I'm looking, I'm going to go back to my red. I'm going to erase a little bit here. Okay. So if I'm going to start with my, at the pole, I'm going to go here, I'm at 0, and I'm going all the way until I get to my next bound. My next bound, even though it's on that horizontal, so logically it kind of looks like it's probably at pi, even though it's in the wrong direction, right? It should be pi. That's one of the places that they cross. Okay. Now, I am going to pick up the other one though. So the other function is going to actually start at pi, and it's going to go all the way kind of until we go back and hit that pole again. When I hit that pole, aren't I now back at 2 pi? And then let's see, the one that I did first, the red was R1, right? And the second one was R2. And it should be a theta. Okay, Gabby, what happened? The bounds. Okay. So do we understand the 0? Okay, we've got the 0. How did I go from 0 to pi? All right, so I know that the places that I intersect, right? It's basically every pi, right? It's 0, it's pi, it's 2 pi, it's 3 pi, it's 4 pi, it's 5 pi, and so on. That's what we're getting out of the fact that when we put these two things equal to each other. So now I know I started 0. The first place that they have to intersect after they've intersected at 0, because they've already intersected at 0, would be pi. Then I go a little bit more, and the next place that they have to intersect would be at 2 pi. If I kept going, the next place they would intersect would be 3 pi. No, it's not always just by looking. It makes sense to me when I look at it. Okay, it's on the kind of the horizontal, so it does kind of look like the pi angle, but it's not always just by, we kind of have to, there's a fine line there. Yes, Lorenzo, we would take the integrals separately. And yes, I will probably only ask for the setup, Natalie. I'm probably not going to, there's going to be something somewhere where I ask for you to integrate something. I want to see the practice, but it might not be on the polar. I think the polar, I think that just getting the setup done is going to probably be where our limit is. No pun intended. Okay, maybe the pun was intended. All right. How are we doing on this now? Can I get a smiley face rating? Natalie's good. Okay. Zeta's good. Where's everybody else at? Okay, Samuel, what's wrong? Is it because you dropped in late? Oh, yes. Okay, Lorenzo added one extra thing. Okay, all right. So look at what Lorenzo's comment. I only got half, right? I still need to do something else to the whole thing, right? I still need to take this thing and I need to multiply the whole thing by 2 to get this other half that was shaded. Okay, thank you for the reminder, Lorenzo. Gabby, what's wrong? What's still? I thought you said not to assume symmetry. So we didn't assume symmetry. It's not assume symmetry when we're touching the two different curves, okay? But we can assume on the vertical. Okay, so on this vertical one, it was okay. On the horizontal one, because we were touching two different curves, it's not okay. Does that make sense? Okay, I'm sorry that the bracket for the smile. All right, I'm good now. So it's like the Lego smile, right? It's the Lego smile. Okay. All right. Okay. That's where I'm going to stop today. Okay. So what you guys need to do before you show up tomorrow is you need to start working through the review. All right. So get on it. I'm going to probably try to focus tomorrow on position, velocity, acceleration-y type things. Okay. I'll probably pull some stuff that maybe I'm thinking about putting on the test. Okay. No, Natalie, I cannot. I'm sorry. They won't let me graduate from Talkwitz yet. I haven't been there long enough. So I got to stay. But you can always go to my YouTube channel. I don't teach the higher level stuff. I promise there's other good math teachers out there. Okay? I promise you'll find one. Okay? All right, Gabby's got a homework question. Let me do the joke really quick. I know you're used to the Ballard way. You'll be fine. You had to do Tyzel's way for half the year, right? Because I know Zeta hasn't been here in a while and she needs a good joke. It's a pretty good one today. All right. And who did you had somebody else? You had somebody freshman year. Was it Prickett freshman year? All right. Did I do the right thing? Yeah. Oh no, I did not share the right thing. So. Uh-oh, I lost Flipgrid. Hang on. I hit my button and closed everything. I lost Flipgrid.